Hello everyone, this is Vidhi Thakur and welcome to a presentation on creational design patterns. Let's start off by answering the question, what are design patterns? Design patterns basically represent the best practices used by object-oriented software developers. They are general and reusable solutions to common problems of software design. A design pattern is not a finished piece of code that can be transformed into final source code, but is more of a template over which we can build our actual solution. Design patterns typically show relationships and interactions between classes or objects. In simple words, design patterns can be thought of as a structured approach to computer programming which is intermediate between the levels of a programming paradigm and a concrete algorithm. Design patterns have two main usages in software development. First, they provide a common platform or a standard terminology for developers and are specific to a particular scenario. For example, a singleton design pattern signifies the use of a single object so that all developers who are familiar with this pattern will make use of one object and they can tell each other that their programs are following the singleton pattern. Secondly, these patterns provide best solutions to certain problems faced during software development as they have evolved over a long period of time. Learning these patterns makes the inexperienced developers more comfortable with software design. So now we know what design patterns are. Let's move forward and introduce a specific type of design patterns called creational design patterns. These patterns basically deal with object creation mechanisms. They try to create objects in a manner suitable to the situation. The basic form of object creation could result in design problems or additional complexity. Creational design patterns solve this problem by somehow controlling object creation. There are many types of creational design patterns, but in the scope of this presentation, we would majorly focus on four of them, namely factory design pattern, abstract factory pattern, singleton, and object pool pattern. Let's discuss each one of them in detail. The first pattern is factory pattern, which is one of the most used design patterns in Java. Here, we create the class objects without exposing the creation logic to the client. It provides an interface for creating objects in a superclass but allows the subclasses to alter the types of objects that will be created. This pattern is also known as virtual constructor. To understand this design pattern in depth, let's take a look at this UML diagram. Here, we have an interface called shape and three concrete classes which implement it. Also, we have a factory class shape factory which is accessed by our main method in factory pattern demo. The main method gives some information to shape factory, and on the basis of this information, shape factory returns a shape object to the main method. Here, the shape interface does not know what and how many subclasses will be required. Also, it wants the main function, that is, the client, to clearly specify which object it wants. The object creation logic is hidden from the client. Next pattern that we will discuss is abstract factory design pattern. It is almost similar to factory pattern, but it is considered as another layer of abstraction over factory pattern. Abstract factory pattern works around a super factory which creates other factories. Its implementation provides a framework that allows us to create objects following a general pattern. So, at runtime, the abstract factory is coupled with any desired concrete factory which can create objects of the required type. To simplify things, let me build an analogy between this design pattern and a pasta maker. So, consider our code to be a pasta maker. Different pasta creating disk prepare different pasta shapes. So, these are our factories. All disks have certain properties in common which allows them to work with the pasta maker. All pastas have certain characteristics in common that are inherited from the generic pasta object. To develop a better understanding of this design pattern, let's take a look at the given UML diagram. Here, the client class that requires product A and product B objects does not instantiate these classes directly. Instead, it refers to the abstract factory interface for creating objects, which makes the client independent of how the objects are created or which concrete classes are instantiated. The Factory 1 class implements the abstract factory interface by instantiating product A1 and product B1 classes. Moving on, let's discuss another design pattern known as the Singleton design pattern. Take a pause of 10 seconds and think about what it means and what it does. Ready? Okay, so let me tell you its meaning. This pattern asks us to just define a class that has only one instance and provides a global point of access to it. In other words, a class must ensure that only a single instance should be created and a single object can be used by all other classes. There are two forms of singleton design pattern. First is early instantiation, which means that the instances are created at load time. Second is lazy instantiation, which means instance creation is done only when required. To make things clearer, let's take a look at the UML diagram of this pattern. Here, the singleton class declares the static method getInstance that returns the same instance of its own class if it exists, otherwise, it creates a new instance. The singleton's constructor should be hidden from the client code. Calling the getInstance method should be the only way of getting the singleton class's object. The last design pattern that I would like to talk about is the object pool pattern. It is a design pattern which is used in situations where the cost of initializing a class instance is very high. Basically, an object pool is a container which contains some amount of objects. So, when an object is taken from the pool, it is not available in the pool until it is put back. Objects in the pool have a life cycle which involves three stages mainly: creation, validation, and destroy. Let's take a look at the given UML diagram. It involves a client class which uses an object of the pooled object type. Then comes reusable pool, the pooled object class type that is expensive or slow to instantiate, or that has limited availability. So, it needs to be held in the object pool. Lastly, we have the object pool, which is the most important class in this design pattern. Object pool maintains a list of available objects and a collection of objects that have already been requested from the pool. Now, I would request you all to pause the video again for 10 seconds and think about possible situations where we could employ this design pattern. Done? Alright, let me tell you one example myself. Think about database connections. It is pretty obvious that opening too many connections might affect the application performance for several reasons. Creating a connection is an expensive operation. When there are too many connections opened, it takes longer to create a new one and the database server becomes overloaded. Here, the object pool design pattern could come handy as it would manage the connections and will provide a way to reuse and share them. It can also limit the maximum number of objects that can be created. And that, my friends, is the end of this presentation. Thank you for watching it.